So we're moving on to lesson 8, talking about how much energy is used. So say like in your household or by your laptop or your refrigerator, and how much would it cost for you. So the first thing we're going to talk about is going back to powers. You have learned power is energy over time. And we have these things called the maximum power rating. It's like every single device, if you actually go home and look at I don't know, your washer, your stove, they all actually have a power rating that helps you determine how much energy and how much it will cost you to pay for the electricity. So obviously, the higher the power of the object, the more cost it would be for electricity. And the equation is basically a rearranging of the equation. I don't know if you remember that we have talked about that work is the change in energy over time. That was from beginning of the unit. So if I'm solving for E, that means I need to move this over. This used to be dividing when I multiply. That's why the T is on the side. Okay, so question 1. What is the power of an electric elevator motor if it uses 2.9 times 10 to the 5 joules of electrical energy to lift an elevator car 12 meters in 16 seconds? Okay, so they're actually asking for power. So we know that power is basically the change in energy over the time. And since we're telling you, they told you that you have your electrical energy, which is 2.9, and they tell you the time. Okay, we actually don't need to use the meters in this case because they already given me the change in energy. So change in energy is 2.9 times 10 to the 5, and I know the time is in seconds, so that's great. I can just leave it in there. So I don't know if you remember how to punch this in the calculator. We learned that at the beginning of the school year. And just a little recall, this is called scientific notation. What we do is you would actually punch in 2.9. The only thing is the times 10. Instead of doing the times 10, you don't even press the times button. You find the EXP button or the EE button that is in your calculator, and then you press 5 and then divide that by 16. Try it out on your calculator. Make sure you're able to punch it in. If not, make sure you ask me. 2.9 EXP5 divided by 16. I got the answer to be 18,125. And if I were to ask you, what is the unit for power? Hopefully you remember that it is what? It is in watts, okay? All right, cost of electricity. I know this is way back old. During the last couple of months, they actually took this off, okay? But now, starting November, they're starting to charge you a different rate at different time, okay? So off peak, mid peak, and on peak, it depends on, if it's winter or summer. So we're entering the winter month. This is the one that we're gonna be using, and the cost of electricity have different prices depending on what time you're using it. The reason for that is the government is trying to encourage you to not all use electricity at the same time. Because if that's the case, because if not everybody is using it at the same time together, even though, your load of laundry will still cost the same amount of energy that used up. But if we have too many people using it at the same time, what happens is it will not have enough energy from the nuclear power plant, and then ended up you would have to use the fossil fuel, which is causing pollution. So that's why it's like a government incentive and to charge you less money if you try to save like things that are non-essential. Like you don't have to go to work, you're at home. If at nighttime you're using electricity, it would not be using at the same time. And some of the other stuff that we have is look at the Energy Stars of the appliances as well as the power rating of your appliances. So government sometimes would be giving an incentive. Oh, if you buy a machine that is more energy efficient, meaning in order to do the same thing is taking up less energy, then they might give you like rebate or something like that. So hopefully in the long run, not only that you save electricity, meaning you're saving money, you're also saving the environment. So a lot of time the government is giving incentive to do that. Okay, so the last thing we're going to be working out is called cost of electricity. How much money are you going to be paying? Okay, so basically the cost of electricity depends on a certain thing. The first one is the device. Is it a laptop? Is it a computer? Is it your phone? The second one is whatever this device is will give you a certain power rating and how much time you're using the device. Okay, the units that we use to measure electrical energy, instead of joules, sometimes we change it to kilowatt hour just because it's a larger number, because it will be hard. Like, see, think of this number here, 2.9 times 10 to the 5 joules is so big. And if I give you a bill at the end of the month and I tell you, oh, your household have used up 5.77 times 10 to the 8 joules, like that, like people are not going to be able to comprehend it, right? So we're turning it into a different variable that is a bit easier to manage. Okay, it's called kilowatt hour. And the cost also depends on the rate. So just now we already talked about different rate at different time. Like, so these are the rates that they were using. I don't know if you can see the rate. Like, these are the different amount of money you have to pay if you use up whatever X amount of kilowatt hour of energy. Okay, so one thing that I wanted you to write down are the units that we want. Okay, and this is the only time. Okay, you know how we've been doing everything in seconds? This is the day that you're keeping your time in hours. Okay, and the reason for that is the rate is always given to you, given as cents per kilowatt hour, or sometimes they say $ per kilowatt hour. So I have to keep the hour consistent. And the power is done in kilowatts. Okay, and to go from kilowatts, sometimes if they give you anything in watts, to go from kilowatts, you're going to divide it by 1,000. Okay, I hope you know how to convert your hours. If they give you something in minutes and they want you to express it in hour, you would divide it by 60. If they give you something in seconds and they're saying how many hours, you're going to have to divide it by 60 and then divide it by 60 again to turn it into hours. Okay, so they're asking you what is the cost of operating a 25-watt light bulb 4 hours a day for 6 days if the price of the electricity is 8 versus 16 cents. So there's two different questions. Okay, 25 watts is power. Okay, but we don't like things in watts. We like it in kilowatt. Okay, so make sure you turn it into kilowatts right away by dividing it by 1,000. So it's 0.025 kilowatts. Okay, the time is 4 hours a day for 6 days, so 24 hours in total. And the rate is 8 cents per kilowatt hour. That's for part A. And we're going to redo the question for part B, but this time the rate is 16.1 cents per kilowatt hour. All right, super big long equation. Equation for cost is power times time times the rate. Okay, power is 0.025 kilowatt. The time is 24 hours, and the rate is 8 cents per kilowatt hour. Okay, so punch that in, 0.025 times 24 times 8. It will cost you 4.8 cents. Does it make sense that the cost is money, and so in this question it would be the cents? Okay, so it costs you 4.8 cents if you leave your light bulb on for 4 hours a day for 6 days in total. Is that a big deal? I don't know, but if you have a lot of other appliances at home, right, that are on. Okay, part B. Now you've doubled the amount of cost because your rate is now more expensive. You choose to use it during peak hour. Okay, so that means you did it, I don't know, between 5 to 7 in the afternoon. That's when you decided to use your light bulb. Okay, if it's at a more expensive rate, how much would it change the cost? Power times time times the rate. Power is still 0.025 kilowatt. The rate is still the time is still 24 hours, but this time the rate is 16.1 cents per kilowatt hour. 0.025 times 24 times 16.1, 9.66 cents. So that's going to be how much it would cost you if you use it during the peak hour.